it in case I need it. Okay. So we started P5 yesterday. We did solve graphically on our calculator. We took the square roots. We completed the square. We didn't do letter D. Should we do that now? Sure. Why not? Whatever makes me happy. Wow. Never has anyone ever said that. That's it. All right. So if we're looking at letter D, your first instinct might be to divide 3 out of everything. I don't necessarily want to do that because at the end, I'm going to need that 3. Remember, the 3 in the front makes a parabola fat or skinny, or it changes it, and so we can't get rid of it completely. So let's move the x to the other side. Let's do 3x squared minus 9x blank equals 12 blank.
I will wash my hands.
Can you put your mask on your face? Now I'm going to factor 3 out of the left-hand side. So I've got 3x squared minus 3x blank equals 12 blank. Now when I go to do my b divided by 2, my b is an odd number. My b is a 3. So I'm going to get maybe a funky thing over here for that. I'm going to get negative 3 divided by 2 squared. Well, that doesn't simplify. It doesn't give me 4 squared or, 1 squared. I have to then just square both parts. 3 squared is 9. 2 squared is 4. So that's what I'm adding into my parentheses is 9 over 4. Do I add 9 over 4 to the other side? Yes, but I have to do one thing first. What do I have to do first to that 9 over 4? By the what? Multiply by 3. So 3 is on the outside and 9 over 4 is on the inside. So I have to multiply by 3 before I move it to the other side. And that's going to be 27 over 4. Getting some weird fractions, but that's okay. We're just going to keep moving like we know how to. I've got 3 times x. I'm going to minus this number right here. You have a question?
Why would you do it by 3?
I factored out a 3 at the beginning because I always want it to be x squared by itself. The number that goes into this spot right here, it's always your b divided by 2, and a lot of you are like, oh, it's just half a b. Oh, it's half a b, and you found that pattern. Now is when we get to use it. It's going to be negative 3 over 2 goes in that. It's not the 9 over 4. It's not 3. It's 1/2 of 3 or 1/2 of b. That's the reason I mentioned it when we had easy numbers is because it's important here. And the other side, oh, I got to do 12 turns into a fraction of 48 over 4 plus 27. That becomes 75 over 4. All right. Divide by 3. Now we're just doing some weird algebra stuff. I'm going to erase this so I can use this side over here. When I divide 75 over 4 divided by 3, is the 3 going to go into the numerator or the denominator? Where is it going to join? The what, Becca? Denominator, very good. So I'm going to have x minus 3 over 2 squared equals, it's going to be 75 over 12 now. That simplifies, right? What's a common term in there? I think just 3. Isn't 75 divided by 3 25? And 12 divided by 3 is 4. This is going to be helpful in our next step. Because now I'm about to square root both sides. And when you square root x minus 3 over 2 squared, then I'm just left with x minus 3 over 2. And if I square root 25 over 4, is 25 a perfect square? Is 4 a perfect square? I'm going to have a nice easy answer, plus or minus 5 over 2. Add your 3 over 2 to both sides. So I've got x equals 3 over 2 plus or minus 5 over 2. I know. Problem just keeps going. Now I have to add and subtract. So I've got 3 over 2 plus 5 over 2. The one nice thing is that they both have the same denominator, so I don't have to do any work besides that. 3 plus 5 is going to be 8 over 2, which is 4. And then I'm going to do 3 over 2 minus 5 over 2. 3 minus 5 is negative 2, and negative 2 over 2 is negative 1. That was a lot of work for some nice, pretty answers, right? I did really want to make sure we did an example of this one, though, because there may be problems in the future where you have an ugly, like an odd number in for your B, and you are able to do it. It looks a little bit different. The algebra is harder, but you know how to do all the steps. All right, let's keep going. Let's practice some quadratic formula. We started that yesterday, but we didn't get too deep entrenched in it. If I look at letter A, I skipped it yesterday because I thought it was going to take a little bit more work than what we did on letter B. What's all the work I have to do on letter A? Say again. Combine like terms. Good. So I got to start combining, bring it down to just be one x squared term, one x term, and one constant all on one side of the equation. So I've got a lot of simplifying to do. I can't really do anything on the left side, so I'm just going to bring it with me. The right side, I'm going to distribute that through. X squared plus 3x minus x squared minus x plus 3. Like terms, oh, those will cross out. Like terms, 3x squared minus 6x minus 7 equals 2x plus 3. And then I just minus my 2x to both sides and minus my 3 to the other side. So then I can get 3x squared minus 8x minus 10. And that was just my setup. So now I can use my quadratic formula. A, B, C. I know. I'm going to scroll over to blank space and then I'll zoom out for everybody to see. I've got x equals negative b, and b is negative 8, so it'll be positive 8, plus or minus square root b squared, negative 8 squared minus 4 times a, which is 3, times b, which is negative 10, over 2 times a, which is 3. So that's how I plugged it into my quadratic equation. Are we okay with that? Quadratic formula. Let me keep simplifying. 8 plus or minus root 64 minus, that's negative 12. Negative 12 times negative 10 is a positive 120 over 6. 64 plus 120 is 184 over 6. I'm sure 184 can factor 2 and 92. And 92 becomes 2 and 46. And 46 becomes 2 and 23. I only have one pair in common though, 1, 2 pair in common. So that's the same thing. I'll put it over here. As 8 plus or minus 2 root 48, or 46, excuse me, over 6. And what can I do, Laura? Take the 2 out. Since I have a 2 in all 3 of these terms, the first one, the one in front of the radical, and the bottom, then I can take that 2 that's in all of them out. So it becomes 4 plus or minus root 46 over 3. I know that was like a lot, but none of that was difficult math or anything that was new. It just was like taxing, right? It was just frustrating. Why did I spend so much time on it? That's kind of what we're doing a lot of right now. Is it's not necessarily hard or new or different. It's just like a lot of time, and you have to be very careful about each step. So make sure you're taking care of your negatives. Make sure you're taking care of as you carry things through to not lose anything as we keep going. Okay. We're gonna leave C for Monday or whenever I feel like getting to that. Let's do a little graphing calculator. Do you have yours with you? If not, I'm gonna pull mine up on the board. Before we put anything in, on the last graphing calculator ones, I said put everything to one side. Can you move things around with like letter A? Can I put things on both sides? It's gonna be kind of funny. On this one, I want us to put one of the equations in for x1, or y1, excuse me, y1, and I want us to put the other one in for y2, and then we're gonna find the intersection of them, okay? So I don't know if we practiced that yet, but we will go over doing the intersection of those two graphs. Yep, and that's also good to practice. I think it's math. I think it's math. Oh, it's second zero? Oh. If you go to the math menu and then scroll over one, I think it's the first one. So let me get mine up, actually. It says abs parentheses. And then if you have one of the older calculators, it should put up absolute value signs. You have one of the newer ones. The older ones don't necessarily do that. All right, so as I'm getting my board ready, you're typing in some of those equations, seeing if you can get them typed. I think we all can see this now. I'm gonna make sure my window is right. You also remember you can go to Zoom 6 or Z standard to get to your normal window. I was doing one of the word problems that we're not gonna get to today earlier, so that's why mine's all messed up. Go to math, go to NUM, 2x minus 1. Is everyone good? Got a little excited there for a second. How did I what? Absolute value signs. Go to math and then scroll over one. Now you're on the menu NUM and the first one says ABS. Press enter. And then it should pop up wherever you were at. I don't know. I don't know if mine just popped up with parentheses or not.
You don't have to.
No, so I had an older calculator for a long time. That's the one I still use when I'm not using my like the computer one. And it doesn't put those up. It just has ABS and it has parentheses and then you have to close the parentheses. So I just got used to that. All right, do you guys have those two formulas on there? Let's graph them. Perfect. These are kind of gross because they're a little bit more on top of each other than I would like, but that's okay. We have to find our intersection. So we're gonna go to second trace and we have to go to number 5, which is intersect. Press enter. This one's about curves. Now it crosses a couple times, so I'm gonna try and get close to one of the intersections versus the other one. So I want this one over here to the left. So I just scooted a little bit closer to it. And that says first curve, so I'm on the blue curve. Okay, enter. My cursor jumps to go to the other curve, which is the red curve. So that is the second curve, that's true. And then you can just say guess and you can just press enter. Sometimes I get just a little bit closer to where they intersect. I don't know if that helps or if that was just how we did it on the old calculators. So it intersects at x equals negative 2.41. I'm going to write x equals negative 2.41. And then we'd go see if there's another intersection. It for sure looks like it intersects over here. It looks like more than 1 point, but I'm guessing it's only 1 point. So I'm gonna go over to this side now. So same thing, second trace, intersect, and I'm gonna scroll over a little bit to get to the other intersection. So I'm still on the blue one, now I'm on the red one, and I'm guessing somewhere over here. And it's gonna say at 1.00006, so at 1.
That's not what I want.
What'd you get?
The first one point. Yeah.
0.41.
Yeah.
There might be another one down here. Let me
I
look.
don't know.
See, it's all kind of messy right there, so I will see. This feels way too close for what I would like, but yeah, now it gives me a point down there. So it looks like it intersects a lot more than what you would think. 0.41. It's got at least 3 intersections there. Okay, so while I am going to stop my recording, though, I don't need to